tiene single threaded single function processing all equals to okay.
Hello. 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 चलो यार लीड क्वेश्चन करते हैं. आ रही है मेरी आवाज क्लियर? हेलो. हेलो. चलो भाई करते ही हैं अब. बहुत टाइम हो गया. तो इनसे बात करना. इंटीजर दिया है. इंटीजर अरे नम्स है और अगर इंटीजर टारगेट है. हमें भाई इनपुट नॉर्म्स 1 1 1 1 1 दे रखी है, टारगेट 3 है। हमें ईच नंबर में 2 चॉइस दे रखे है, सेलेक्ट करें। बट हम जानते नहीं है, प्रॉब्लम ये है आइडिया सब्ट्रैक्ट करें। तो चल ट्राई कर लेते हैं। रखते हैं डायनेमिक प्रोग्रामिंग से करते हैं। तो काउंटर 0 0 1 हो गया, तो 0 टोटल नंबर हो गया जो हमने करा, और 1 काउंट हो गया। तो बेस केस देखते हैं 1 by 1। Well, we found one at index 0, so we can create 1 and 1 minus 1. Then counter is equal to 1 slash 1 and minus 1 1. This this means we can create one total 1 and total minus. Use counter for the next number also. Actually, we try both case. Now we have one total 1 and one total minus 1. So the formula is each total in hash map plus minus new number. So 1 plus 1 is equal to 2. 1 minus 1 is equal to 0. Minus 1 plus 1 is equal to 0. Minus 1 minus 1 is equal to minus 2. And counter should be 2, 1, 0, 2, minus 2, 1. With 2, 1, index 0 and index 1. So we can create one total 2 and 2 total 0 and 1 total minus 2. Next we found 1 at index 2. Then we have 2, 1, 0, 2, minus 2, and 1. Use the formula and implement 2 plus 1 is equal to 3. 2 minus 1 is equal to 1. 0 plus 1 is equal to 1. And 0 minus 1 is equal to minus 1. 0 plus 1 is equal to 1. And 0 minus 1 is equal to minus 1. And hold a second, guys. And minus 2 plus 1 is equal to minus 1. Minus 2 minus 1 is equal to minus 3. The counter should be 3, 1, 1, 3, minus 1, 3, minus 3, 1. Now I hope you understand concept of algorithm. Let's skip that. After we have counter like at index 3, 4, 1, 2, 4, 0, 6, minus 2, 4, 4, 1. At index 4, like 5, 1, 3, 5, 1, 10, minus 1, minus 3, 5, minus 4. Target is 3, then turn is 5. Let Let the coding. Okay, then we code. We will write the code. Then what was happening. Counter dot put zeros less one. Teaser new hash map. Entry counter dot get key and count is equal to and get value. Counter get for default or Run it. Mm, yes, awesome. Spelling mistake. Yeah, accepted. Then I look at the algorithm and like step one initialize a counter hash map like counter 0 1. And the purpose is this dictionary stores the possible sums and the corresponding counts, like the number of ways to achieve that sum. So initially 0 and 1. Th- This is one way to achieve the sum 0, which is by doing nothing. And second step, iterate over each number in nums. For n in nums, the purpose is process each number n in nums and update possible sums. Then I create a temporary hash map for new sums. And I also that purpose is a temporary dictionary will store new possible sums and their count as we update this. And then the step for iterate over the existing sums and counter. For total counter dot items. Like the purpose loop through all previous stored sums and their occurrence count, and then compute the step 5, then compute the new possible sums. Temp Bright total plus n is equal to temp dot total plus n is 0 plus count, and temp total minus n is equal to temp dot get total minus n is equal to 0 plus 1. In purpose for each total in counter, compute to new sums, adding n to total is total plus n, and subtracting n from the total minus n, and then updating the count. If total plus n, total n minus n is already in temp, increase its count by count. Otherwise, initialize it with count. Update counter is equal to temp. Replace counter with temp so the next iteration consider only new sums. It has ever return the count for the target sum. Return counter dot get bracket target and whole 0. Purple return the number of ways from target from counter. Not from return 0. That's all. I hope you understand. Then we will go into the next question. Yes, right. That's the question. Question number 5 to 6. Beautiful arrangement. Because you have lived it one through learning. Like in tutorial it tells we need the count solution, so I think we use backtracking here. What was the approach? Like, we can use a very old counter isn't valid and need an array to check what value is used. Uh, so time complexity is P1 and space complexity also again. Let the code return 0. Backtrack new put it down in comment section guys. Where are you from? Where are you from? And value. Let me go run. Otherwise, that's okay. Let's see. That India. Okay, but we'll see it run or not. One second, guys. I copy and then I paste it. Okay. This is one doing. Yeah. Okay. Still run. Here we go. Please do guys subscribe my channel. How much we have got? Leave 22 questions. 270, 370. Like within a month, I have to do 400%. Like, okay, we have to do one question of my results. Hard level question can that's Okay, the cave booking happens when key events have some known empty intersection. But you are given some events, start time, end time. After each given event, return an integer k representing maximum k booking. Here the example is I think first of all we should increment for the starting time and then decrement for the ending time. Like +1 for start and -1 for end make 0. Once one event ends, then traverse map in order to find preview maximum intersection booking. Oh, okay. Let's see code. Private map flash integer user lines and remap dot as default start. Here can we go adding one mouse black and slash Nice. Not or default. After write the code, I will explain also. Don't worry. Okay. Let's what do you see? Error here. What is the error? Teaser. Teasers. Nice. Okay, guys. I will explain the code on. Oh, listen, like time complexities, we go n square. And space complexity, we go n. And okay, very like can I use array list instead of devs? Many suggestion given that the constant state zero greater than equal start then greater and greater than is equal to 10 if all 9. It means we need to sweep from 0 to 10 raised to 1 line if we use array list. Let's say the books are 10, 20 and LE 9 minus 10 and LE 9. Then the raise 20 LE 9 minus 10 minus 1 is empty, but we still spend time to check them. But in Java, we can use tree map instances since we only have at most 400 calls. In line sweeping, we need to ensure the keys are sorted. Tree map is implemented as red black trees so that it fulfills lines bracket 1 is equal to j where we have j overlapping elements at the point I. Then we write, look, hold on guys, that is run. Check it. And notice time. Okay, we will see. 12. Yes, that's accepted. Nice. Look, then like after the private tree map integer, then finding number of overlapping elements at the points at the time points greater than line sweeping. Then new events are starts here and increase by one. Like what we write lines dot put to start lines dot get or default start this is 0 plus 1. And the event ends here and decreases by 1 after the second line. And sometimes you see lines end plus 1, example like 2406. Divide divide intervals intro minimum number of groups. You may search Leetcode the hard way. This is because the interval is inclusive. For example, like start slash end. However, the interval in this problem is start slash end. We don't need to add one here. Here we calculate the prefix sum and record the maximum overlapping intervals. That's the code, and I have to run this code. So there's the conclusion done. Okay, create question done. Okay, one more question I will do. And yes, there's Wo scene. I also part in content and I'm also streaming there. Today is a constant in 8 a.m. 8 p.m. Sorry, guys. Yes. And my suggestion is all of the you guys are participate in a contest and improve your problem solving skills. We will like that's the question. Action to make sorted. Okay. Given an teaser array of length and negative percent a permutation of the integer in the range 0 slash n minus 1. We split array into the number of chunks and individually sort each chunk. After concatenating them, the result should equal to the sorted array. Here we use some examples. How to approach this problem. What was the introduction like? We aim to split the array into chunks where each chunk can be individually sorted and their concatenation result in a sorted array. By leveraging the properties of permutation and indices, we can determine valid chunks based on running sums. So, like uh, we in approach, we use two variable running sum, running sum for the sum of elements so far, and expected sum of indices so far. Then traverse the array in the next step. If running sum is equal to expected sum, we can form a chunk since all elements up to the current index are in the correct order after sorting, and count the number of such chunks and return the result. Like for example, if in example one array is equal to 4 3, so at index 0 running sum is equal to 4, expected sum is equal to 0, not a chunk. That's the proportion. At index 1 running sum is equal to 7, expected sum is equal to 1, not a chunk. At index 2 running sum is 9 and expected sum is 3, not a chunk. At index 3 running sum is 10 and expected sum is 6, not not a chunk. At index 4 running sum is 10 Expected sum also 10. Then the check found. Mm, that also you do the second example also. And the guy's time complexity is big of n for the single traversal of a array. And space complexity is 0 big of 1 constant speed is used. Okay, then write the code. Int running sum equal to 0. Expected sum also 0. Chunks also 0. Then you use loop. Array dot length increment and some. Please guys subscribe my channel. Expected sum I if running sum expected sum. Then chunks increment return chunks. Then we run the code. Combine. Oh, sorry. Yeah, run the code and I have to submit the code. Man, okay, that's it, guys. If you ask the question down in the comment section, okay, one guy is here. But you have to ask any question. I think is giving is not there. Okay, then I think we will do one more question. Okay, one more question now. Mm, String function. Easy function. Violet parts. Given the root of a binary tree, and return all root to leaf paths in any order. Okay. First of all, we will do a brute force approach. And brute force would be perform a DFS of a binary tree, and at each node, with all possible paths from to that node. So we can use a recursive approach to traverse the tree and construct paths as we go. So look like a algorithm approach. Start at the root of the tree and then initialize an empty list as like array list to store the path and define a recursive function like DFS takes the current node and then the current path and the list of paths as parameter. In the DFS function, if the current node is null, return append the current node's value to the current path as a string. If the current node is a leaf, both left and right children are null, and convert the current path to a string and add it to a list of paths. Cursor call DFS on the left child with the update path, and cursor call DFS on the right child with the updated path. Then call the DFS function starting from the root node with an empty path and the list of paths, and then the return the list of paths. Here we go. Then the writing. list string result new enter result private node DFS node node string path list is if node is null current node's value to the path path node that one and if towards a leaf node when add the paths to the result list if slash node not left is equal to null and not dot right result else separate node several nodes in the paths DFS nodes node left and path salt node slash node dot right path result. Okay, then we run the code. Oh, sorry, guys. That's yeah, node, yes. Okay, they done the code and we have to submit. Accepted. Okay, then I what? How many questions we have done? 376. Like in this, do four question in 1 hour. One easy, three mediums. Okay, just good. Just maximize this. Just after removing one conflicting, to the rare conflicting pair, when conflicting pairs avoid A and B indicate that's a number, and A and B form a conflicting pair. So write the approach. Our single pass game is as follows. First of all, organize conflicts. First of all, conflicting U values by their endpoint V, and an array of list right is perfect where right is V stores all used to four conflicts C and V. Then then second step, initialize we all create three variables to manage our sweep. ENS for an accumulator for the base score starting at zero. Left a two element list like top one, top two, initialized to zero. This takes the two most restrictive U values seen so far. Left is 0 pixel or running forbidden start. And the third bonus, an array size n plus 1 initialized to zeros. You'll calculate the total score again if the critical conflict in- involving use the one they choose to remove. And the third step, we will get a single save. We iterate with the variable r from 1 to n, and in each iteration we perform these three actions. First, like update state, check right r for any new conflict, ending at r, and use this the update to left is equal top one, top two, ensuring it always hold the two largest values and counter up to this point. Okay. And then second, calculate base contribution. The current top one left zero is the most restrictive forbidden start. The number of valid sub-arrays ending at R is equal to R minus left zero, and we add this to our answer. And the third, the calculate bonus contribution. The difference left zero minus left one is the gain we would get for the specific step R. If the top one conflicts were removed, we add this gain to the bonus left zero. Effectively treating the conflict U is equal to left 0 or the potential score increases. And then we have got the last step, final result. After the loop, uh, answer hold the total base score. The maximum value in the bonus array is the largest possible gain. Can we get the final answer? Answer plus max bonus. Like for the, we use an example. Like use n is equal to 5. Conflicting pairs is 1 and 3, 2, 4, and 1 and 4. Pre-computation building the right array, we started empty right array of list size n plus 1. Right is always null. We cross each pair A, B input. And we are like 1, 3, the larger number is 3, smaller is 1. We add 1 to the list at index 3. Right is now, and second 2, 4 pair. The largest number is 4, smaller is 2. We add 2, add to the last at index is equal to 4. So right is now, and the four, fourth array and fifth array is 1 and 2, and rest of the nulls. And the third pair 1, 4, the largest number is 4. The smaller is 1. We add to the last at index is 4. Right now is 1, 2, 1, and rest is the all final array. So looking guys, time complexity is V of n plus p. Like where the n is input integers and p is number of conflicting pairs. Where- and V of p is building the right array takes. And n times they work because main loop runs. And the inner loops that process new conflicts at R runs at a total of p times across all outer loop iterations. And space complexity V of n plus p. The right array requires V of p space to store the pairs and V of n for the list itself. The bonus array requires V of n space. So we write like the code. Okay, then we write code. Hold 1 second, guys. Here we go. Import and not util array list. Import Java util new array list. And plus 1 whole half int is equal to 0 plus I plus right I is equal to nearest force int pair conflicting pairs. Right, equal to math. Go to pair 0, pair 1, not add math not min pair 0 equal to 1. Sorry, is equal to 1. Or agreement yes and plus right manually updates top 2 values. One second, if it's on priority. No, hold on. Attention steps. equal to 0. Left int left 0 left no that's to 0 yes and bonus yes max bonus B. Okay, then return answer plus max bonus. I think run this code. Nothing. What was with the bracket? Then to run this code. Yeah, we'll succeed. I have to submit this question. This question. Okay, then hold on. We copy this and like paste it. Okay, submit this code. Accepted. Yes, 30 days. Okay, then let's end the stream here.